Welcome to this session. I was just hacking a Flutter application. Are you taking Flutter security very seriously? Because Flutter team does, and so do I. According to some statistic, more than 75% of mobile applications will fail basic security tests. This is quite interesting. Even though we are developing Flutter applications, they're still gonna run on Android and iOS and different platforms. We need to take care of the security of Flutter applications on different platforms. My name is Majid, and I am a Google developer expert for Flutter and Dart. And in this session, I'm gonna walk you through Flutter securities, not only Flutter securities, but the top 10 OWASP security risk. Let's get into it. Flutter security strategy is based on 5 key pillars. Identify. Track and prioritize key security risks by identifying core assets, key threats, and vulnerabilities. Detect. Detect and identify vulnerabilities using techniques and tools like vulnerability scanning, static application security testing. Protect. Eliminate risk by mitigating known vulnerabilities and protect critical assets against source threats. Respond. Define process to report, triage, and respond to vulnerabilities or attacks. And recover. Build capabilities to contain and recover from an incident with minimal impact. In this session, I'm going to actually tell you the top 10 security risks for Flutter, which is probably going to cover detect, protect, and respond categories. Let's get into these top 10. So let me introduce you to OWASP. The Open Web Application Security Project, or OWASP, is an international nonprofit organization dedicated to web and mobile application security. The OWASP Top 10 Mobile is a regularly updated report outlining security concerns for mobile applications security, focusing on the top most critical risk. In fact, if you're looking at OWASP website, you will see OWASP Top 10 Security Risk for Web, which is also can be applied for Flutter applications or mobile applications. It's not like we're going to get rid of them or we're not going to cover them. We're not going to talk about them in this session. We're going to focus on the mobile part of the security because this is the most used use cases for Flutter applications. But maybe in another session or video, I will come back to you with the top 10 web security risks. Let's focus on the top 10 security risk for mobile applications. This is based on the latest report by OWASP organization. Improper platform usage. The first item among OWASP top 10 is improper platform usage. Platforms such as iOS, Android, or Windows Phone provide different capabilities and features that you can use. If the app does not use an existing function or even use it incorrectly, this is called improper use. Let me give you some examples. Misuse of iOS Touch ID features, incorrect use of iOS keychain, or requesting excessive or wrong platform permissions. There are different solutions that you may use to protect your application from improper platform usage. For example, what if you restrict the file access permissions? What if you use some of the best practices and guidelines in order to adhere to the platform development use cases? In Flutter, you can do several things to make sure that you are mitigating this issue. First of all, stay up to date. The latest Flutter is stable. Try to make sure that you update your libraries and Flutter applications. Try to make sure you're following the guidelines for publishing an application properly, or regularly checking security guidelines by Flutter team. You always can find them on docs.flutter.dev/security. Another thing that you can do in Flutter is to make sure using any package or plugins that can help you for permission handling. Always request a permission that is needed. Insecure data storage. Insecure data storage, as well as unintentional data leaks, also fall under the OWASP Mobile Top 10. Mobile application penetration testing tools help uncover such problems. However, it does not necessarily have to be your SQL database. It could be manifests or log files, cookie storage, or cloud synchronization can also be affected. Let me give you a couple of examples. When you're storing sensitive data unencrypted in storage, or you storing sensitive data in shared preferences, there are a couple of solutions to fix this in different mobile applications development. For example, encrypting effectively, obfuscation or protection against buffer flow and so on, or avoid storing sensitive data to a storage that can be so visible. I mean, when we are talking about sensitive data, we're talking about username, passwords, authentication tokens, and maybe personal informations that should not be part of the unencrypted storage. In fact, in Flutter, there are a couple of ways that you can mitigate these problems. You may use packages that are heavily using platforms' native way of handling these kind of encryption for storing data. For example, Flutter Secure Storage is one of those plugins that you may want to take a look. Hive is another package that is blazingly fast, and you can use it as a key value database in your application, which is using a very strong encryption, AES 256. One of the common issues that I have seen is, in fact, not protecting snapshots or background snapshots. Well, you may ask, when should I do that? I mean, not for many applications is necessary, but if you're doing an application that provides, or a page that provides a sensitive data when it goes to the background, so maybe you should secure your background snapshots. You may take a look at the packages such as secure applications in order to secure your background snapshots. Insecure communication. Your app transports data from point A to point B. If this transport is insecure, the risk increases. The biggest problem is the transfer of sensitive data from one device to another. Well, let's take a look at some examples here. When you don't use an encrypted data in transit, for example, not using a proper SSL, or not using a proper CA certificate, or sending sensitive data such as password via clear text to another point, which is going to be intercepted somewhere in the network. One of the solutions that you perhaps can do in Flutter is using packages for HTTP certificate pinning. A certificate pinning allows mobile applications to restrict communication only to serves with a valid certificate matching the expected value or PIN. The connection is terminated immediately if communication is attempted with any server that doesn't match this expected value. You can start doing that in Flutter by using HTTP certificate pinning. You should do it properly, otherwise it may even bring more security risks to your applications. Here is an example that you can take a look at the video and see how it works. This is extracted from the certificate pinning package. Another thing that is even the unencrypted communication, or this problem is not necessarily a mobile developer problem. Still, you need to communicate that very well with your team and with anyone who is responsible to making these connections very secure. Insecure authentication. Here are many different ways that an app can provide insecure authentication. Let me give you a classic example. A classic example is a backend API service request that the mobile executed anonymously without relying on an access token. Additionally, there are still apps that stores password locally in clear text. There are a couple of other examples that I can provide you to give you a better understanding. Like, for example, only relying on client-side authentication or relying on a local authentication, which may be tampered. There are different solutions to definitely fix this. For example, avoid local authentications method only. Rely on server communication to validate these authentications. You may even implement multi-factor authentication, MFA, or disallow using all 4-digit pins as password where it's feasible. On top of server-client authentications that you usually do in your application, you can also add a strong authentications for locally validating your user, for example, adding biometrics. Local auth is a package that may help you to achieve this. But do not forget that you always need to make sure that this authentication is also valid by communicating with your server. Insufficient cryptography. The insecure use of cryptography can be observed in most applications. Well, this is almost always one of two problems: a fundamentally flawed process behind the encryption mechanism, or the implementation of a weak algorithms. There are different solutions to mitigate this problem. So when you are going to use any type of algorithms, you need to make sure that they are still valid. And if they are depreciated due to some security risk, please do not use them. Here's some of the examples. MD5, SHA-1, or MD4. So you need to be careful for what reason you're going to use these encryptions. Instead, use encryptions that are fully secure and valid in the industry. So another thing that I want to point out here in this section is secure your developer identity. So in Flutter, usually you are facing with key.jks, or you are facing with some key store.properties, which they are very sensitive. So avoid keeping track of unencrypted sensitive data in your repository. Make sure you are encrypting all of these sensitive files in your applications. You can use GPG, for example, to secure these files. Another thing is that take a look at your encryption keys in your application. You may be able to encrypt your plain text in your application using packages such as Encrypt or Crypto, which they provide some strong algorithms to encrypt your plain text. Take a look at these and make sure you are encrypting your data properly in your Flutter application. Insecure authorization. Unlike authentication, authorization deals with verification of an identified person. It means what this person can do. So, failing to verify a user and grant a permission is a big security problem in mobile applications. Another example of this problem could be only relying on client-side authorization, which can be tampered. The solution could be always verifying your request with backend, or make sure you're validating the roles and permission with a trusted server. Poor client code quality. All vulnerabilities from code-level errors can provide attackers with a way inside. The main risk lies in the need to make localized changes to the code. In particular, insecure API usage or insecure language constructs are common problems that you need to fix directly at the code level. especially when you are integrating with a third-party libraries without checking code qualities. You need to be very careful about this. There are different solutions to this, like enforcing the good quality practices, remove what is not needed, perform static code analysis, for example. Use automated tools to test memory leaks, code tampering, or code manipulation. From a technical perspective, any code on a mobile device is vulnerable to tampering. This is just because the mobile code is running in a foreign environment. It is no longer under the control of your organization. Therefore, there are numerous ways to modify it at all. There are definitely a couple of solutions here in Flutter applications that you may need to take a look at that. But one interesting thing that I need to mention here is this is a very serious problem, especially when a routing attack or a jailbreaking is happening. So in Flutter applications, you may use packages such as Flutter jailbreak detections to detect these kind of problems. Reverse engineering. Attackers who want to understand how your application works can use reverse engineering to access all the information they need. Especially metadata is a high risk. Basically, if you can clearly understand the string table of the binary or cross-functional analysis is possible. The app is considered at high risk. Deobfuscated code, for example, using the tools such as IDA Pro or Hopper, it's possible. So the solution here is that you need to always make sure that as much as possible, protect your application to be decompiled, insecure, and make sure that a robust obfuscation, including metadata, is added. Using binary packages to prevent attackers from decompiling code, or block debugging tools, especially in production, environment. So in Flutter, you get part of the solutions at least for free out of the box. For example, for obfuscation for an APK application in this command line, if you just pass -- obfuscate, you will get your obfuscated application or code. You build binary, so while Flutter takes care of your binary build out of the box, you can read about it on the documentation. Extraneous functionality, hidden backdoor functionalities, or internal security controls are a common problem in mobile applications. The problem with them is that they're not only useful for developers, but also for hackers. This allows them, for example, to disable two-factor authentication or change basic functionalities. Well, here is the thing. A developer may accidentally include a password as a comment in a hybrid applications, or disabling two-factor authentication during testing and actually deploy that to production mistakenly, or having a function as a backdoor for doing something in your application. The solution here is that you always need to examine the app's configuration settings to discover any hidden switches, or verify that all test codes is not included in the final production build of application. Make sure you're also deleting unwanted and unnecessary comments or functions that are opening these doors to attackers. You also need to examine all log statements to ensure nothing is descriptive about the backend. That is being written in the logs. But you may ask now a question. Is that possible to mitigate some of this problem, like on the fly, not just statically, but dynamically analyze these problems? The answer to this could be RASP. Runtime Application Self-Protection, or RASP, is a security solution designed to provide personalized protection to applications. It takes advantage of insights into an application's internal data and states to enable it to identify threats at runtime that may have otherwise being overlooked by other security solutions. In fact, there are 5 different types of attacking that RASP can shine over there. For example, hooking, rooting, or debugger or using application in emulator environment. Fingerprints tampering is also another problem that RASP can work pretty well for this kind of attack. Can you use that in your Flutter applications? Well, the answer is there are different attempts to create Flutter packages for Flutter. Well, there are different attempts to create RASP packages for Flutter. One of the best out there, which I tested and I recommend to take a look at that at least, is free RASP package. Using this package is pretty straightforward. You will get Android callback class, which provides different properties to listen to different attacks and gives you a callback to do whatever you want, both on Android and iOS. Stay with me in this channel, and I'd like to see you in the next videos.